So here you have your practice test, and I've done, the other video has got the answers to that, so you'll have to look at that. So question 3. For the following situations, list what outcomes are possible. State whether the outcomes are equally likely or not likely. Flipping a coin, possible outcomes. Heads, tails. 1 mark. Equally likely? Yes. Another mark. Drawing a marble out of a bag that contains 5 blue marbles. So I'm just going to go 1, 2, 3, 4, 5 and 3 red marbles. 1, 2, 3. Okay. Possible outcomes. Blue or red marble. Equally likely? No. What's the probability of a blue marble? 1, 2, 3, 4, 5 out of 8 marbles. What's the probability of a red marble?
3 out of 8.
3 out of 8. Okay. So they're not the same? So they're not equally likely. Rolling 2 dice and adding the numbers together. This is our dice race. This is our snail race or our bingo thing or what have you. What are the possible outcomes?
2 plus 6, 8, 10,
2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. Yeah? Am I right?
12. Yes.
Okay. Equally likely? No.
Yes and no.
Hang on. Are they equally likely? Can you remember our...
You can't get a 1.
Yeah, but hang on. Remember our UFO dice race? It was a triangular distribution.
Oh, right, yeah.
Actually, I want to do that again, just quickly. If we had... Okay, so we had... This is something you need to know off by heart. Dice number 1. 1, 2, 3, 4, 5, 6 can be on dice number 1. Dice number 2, 1, 2, 3, 4, 5, 6. So, remember we're adding them. So 1 plus 1 is 2, 3, 4, 5, 6, 7. 2 plus 1, 3. 2 plus 2, 3 plus 5, 6, 7, 8. What happens?
4.
5, 6, 7, 8, 9. Because 6 plus 3 is 9. 4 plus 1 is 5. 4 plus 2 is 6, 7, 8, 9, 10. 6, 7, 8, 9, 10, 11. 6 plus 1 is 7. 6 plus 2 is 8, 9, 10, 11, 12. Right. What's the possibility of getting? Doesn't work. A 7. So possibility of getting a 7 is 6 out of
12.
how many outcomes?
What's it?
Oh, yeah.
What
36. Because we have got 6 by 6. We've got 36 equally likely outcomes. Okay, so now we're going to look at what's the probability of getting a 12. 1 out of 36. And what's the probability of getting a 5? 4 out of 36. Okay, so are they equally likely?
No.
No. Okay, so back to our test. So equally likely? No. Alrighty. A loaded dice is... So that means it's weighted. It's not a fair dice. Okay. It's weighted on one side so that one number is more likely to come up. Carissa thinks a die is weighted to make the number 6 more likely.
So the 1 would be heavier side.
She tries... Oh, that's clever. She tries to prove this by rolling the dice 60 times. So 28... Alrighty, 41 plus 14 plus 28. I suspect it adds to 60. Can anyone confirm that?
No, it doesn't.
It doesn't, but she rolled it 60 times. Oh, I'm not reading the question. First 60 rolls, second 60 rolls, third 60 rolls. Right. Okay. How many sixes would you expect in 60 rolls of a fair dice? So I think we've got to go 41 plus 14 plus 28 and divide by 3. We've got 3 trials, the first trial, the second trial and the third trial. We're going to take the average of those trials. So what did those add up to?
Yeah.
What is it? 83. And what's 83 divided by 3? Is it 83?
Yeah, it is 83.
It is 83.
14 plus 28 is 42 plus 41.
Okay, so we've got that 83 divided by 3.
Abdul.
Okay, so that was 27.6, so that would be 28, but we've read the question incorrectly, thanks to Rob. He's pointed out that it says a fair die. So for 10, that 1/6 is actually 10 rolls. So 10 rolls would be fair, and our experiment was 28, so it actually is not a fair die. So the answer there was 10. Based on the experiment, would you conclude that the dice is loaded? Explain. So the experiment, you would write the experiment indicates 28 out of 60 is 6. Oops, it says 6. What? Oh, sorry.
Next page.
Yeah. Which is almost half. Very different. Very different to 1/6. So, based on the experiment, would you conclude the dice is loaded? Yes. And your explanations will all be a little bit different. But it's really good if you've made that calculation, because that would be excellent to actually have that calculation in there. Alrighty, moving on.
This was a good question.
Oh dear, sorry, I'm quite bad with this, aren't I? Question, you had a bit more room there. Question 5. Jade wants to predict how likely different weather patterns are. He records the main weather pattern each day for the month of April. Okay, so that's your weather and that's the number of days. Okay. Based on Jade's results, give the probability of showers as a fraction and a percentage. So showers is 5 out of 30. So 5 out of 30, so that's 1/6. And what's that as a percentage? 1 divided by 6 on your calculator is?
Oh, it's I figured this out.
Can't be
It
0.16.
was 4. It was, yeah, 16.
1 divided by 6.
What Vince said, 16.66.
Hang on. Okay, so we actually did get though 1 divided by 6 to be 0.17. Was 666 recurring?
Yes.
Yeah, or 16.7%. 16.7%. I think that's why sometimes people get really confused with fractions, because they learn that one, and 1/6 is 0.166, and they think then 2/3 is 0.23.
I just do 100 divided
Yeah.
by 6.
So can you still write 16.6 recurring?
Yep, 16.6 recurring is fine. Okay, so I don't know that off by heart, that fraction. It just seemed wrong. Right, based on Jade's results, what can he say the most and least likely patterns are? Okay, so what's the most likely? Overcast, and the least likely? Showers. That's the biggest number, that's the lesser number. So the most likely overcast and the least likely is showers. So we're getting points there and points there. Nice. Correct me if I do anything wrong, won't you? Explain why Jade can't say for certain that his results can be used to work out the probabilities of weather patterns next April.
You can't
The
go that
season
far.
could be different.
It could be different. It's not the same. So the idea there is variation. Okay? But randomness. It's like every April is not the same, so you can't really use that. Give another problem with the reliability of Jade's experiment.
Other problem.
4 seasons in one day.
Oh yeah, true.
On a day, it can rain, it can be sunny, it can be all of those things all in one day, can't it? So
Yeah. Yeah.
if you look here, do these add up to 30? Yeah? So that's 19, so they add up to 30. But in one day it can rain, it can be sunny, it can be overcast and showers. So it doesn't really work. Because you've got to allocate a day to a weather.
Yeah.
And that's hopeless. Absolutely hopeless. Because the weather doesn't work like that. Okay, carrying on. Next page. Oh, I've done this one already. I've videoed that one, yeah.
Damn.
Oh, the chocolate.
The chocolate one I've
That was
videoed.
easy.
Chocolate one.
Yeah.
Yeah,
I
you
don't
just-
think I've done
I
this one. You just
and
have
then
to
I
name
think
all
I've done the
things.
marble one. Where did I stop though? Do you guys
Can you still do it?
this one here?
Yeah.
So basically that's trial 1. They're putting the marbles back in the bag, so that's still, you can have a red or a black, a red or a black. So it's red, black, red, black, red, black, red, black.
Yeah, that's all.
And then here, that's 4/7 still, that's 4/7 still, doesn't change. That's 3/7, that's 4/7. You're getting the pattern? 3/7?
Wait, what?
No?
What?
Well, every time that you
Oh,
go
yeah,
for
yeah,
red,
yeah.
there's
I've
4
got it.
red,
Yeah.
there's 4, 1, 2, 3, 4
I was just
red
looking.
ones, and then there's 3 black ones. Oh, sorry, I've got blue. So that is always the same. That's always 3/7, and the top one's always 4/7. Okay. What is the probability that the first 3 people who take the drug are cured? So what's cured?
Oh, the there was a thing before. The question was a guy. Yeah, you were saying.
Yeah. So 4 were red and 3 were black, and 4 out of 7, the new drug has 4 out of 7 probability of curing. So the 4 is cure. So if we looked at that, that's cured. The first 3, so that's cured, is 4/7 times 4/7 times 4/7.
Oh.
Because you multiply along the branches. So that's going to be 4/7 times 4/7 times 4/7, which equals
Top 64.
This one.
no, whoops.
Francois
Yeah.
calculator.
Is it times or
So
plus?
4/7. It was times
Oh, okay.
times
Can I just go
4/7
times 3?
times.
No, because that will
4
work.
over
'cause the
7.
four,
Oh,
Or
yeah,
you
yeah,
could
yeah.
go bracket 4/7.
Oh, you got 9.
Nah. Bracket 4/7 to the power of 3. Okay? And then I could hit
That's what that will.
that one, 64/343. 64/343. Okay. Then we've got Samuel does the experiment 70 times and pulls out a red marble 32 times. Explain what this would represent in the real life situation.
32 people would be cured.
Yes. So the red was the cure. So 32 people
That's just under half. There.
cured out of
70.
70 people.
the other